how do you factor a cubic polynomial? For example, look at this intimidating. Y equals x to the third minus 3x squared minus 4x plus 12. How do you factor this? Well, first of all, let's write a cubic polynomial in its generic form. So you have a coefficient, coefficient, coefficient. The highest power is a third, and then you have a second, you have a first power, and then you have a constant. So the first thing to understand is the first principle of the factor theorem. What is the factor theorem? So assume this is a polynomial. If we plug in a number for x and the resultant is 0, that means that x minus that number that we plugged in is a factor of this polynomial. So why does this theorem make sense? Well, we have to go back to Algebra 1. Remember when we first learned about graphs? When can we solve for x? When it intersected the x-axis. What does it mean when it intersects the x-axis? It means that the y is 0, right? If the y is 0, it's intersecting the x-axis. So it goes all the way back to Algebra 1. That's the first principle you have to know to understand how to solve a cubic polynomial. So now let's think about how you get a cubic polynomial. I can think of two ways. One way is an x plus or x minus a number times x plus or minus another number plus x plus or minus another number. Or you could have a case where it's x plus or minus a number times, this is a quadratic, so it's a second power. It just can't be reduced more. So these are two cases I can think of. Now, what's a common theme between these two cases? The factor theorem will get us one of the factors of this constant, because this constant is the product of this number and some other numbers. So now let's list out all the factors for 12. 1, 2, 3, 4, 6, and 12. Of course, we have to say it could be plus or minus, right? It could be positive or negative. So let's apply the factor theorem. We set y as 0. And what do we do now? We plug in the values. So if we plug in 1 or negative 1, we're definitely not going to get 0. So then we're going to plug in 2. Let's plug in 2. 2 to the third is 8. 2 to the second is 4. And then 4 times 3 is 12. So 8 minus 12 is negative 4. That's 0. So we just found a factor of this equation. So let's write that down. So remember, we write x minus 2 because if we set that equal to 0, x equals 2, right? That's why it's x minus 2. So now that we have this as one of the factors, we can, of course, try to plug in all the other numbers and find the other factors according to the factor theorem, or let's divide this cubic polynomial by this. Do you remember how to do long division, guys? So this is where your second first principle comes into play. We can break any number into parts. So for example, the numbers that we're familiar with, because we're base 10, aka we count with fingers until 10, right? You can break it down into a 1's digit, a 10's digit, a 100's digit, etc. You can do this with any counting system, so it doesn't just have to be base 10. You can go to the next digit at 8, or a lot of you understand computer language, you know, it's base 2. So it's 0, 1, and then the next number goes to the next digit. So when you're doing long division, you're breaking the number up by its digits, and starting at the highest digit with the number that you're dividing, you go this way. So knowing the method behind long division, and knowing we normally just are base 10, and you can indicate base 10 this way, does this kind of look similar to something up here? You can apply this same logic. There's some kind of base here, and you're basically going up the digits. You can take that same philosophy and divide a polynomial. Since we have a units digit and then another higher power, we have to divide this into two of these. So let's think about this. What can we multiply this by to at least get rid of this digit, right? So now let's multiply and subtract. Negative 3 minus a negative number would be negative 3 plus, right? So we would get negative 1. So what do we do in long division? We carry the next power down. Let's go back here. What now can we multiply to get rid of this? Negative times a negative, right? So now if we do a negative minus a negative, that's plus. So we can get rid of this. And then a negative times a negative is a positive. What is negative minus a positive? It gets more negative. And we bring down the last digit. See, can this go into this? And lo and behold, it can. Look at that. Negative 6, negative 6x, plus 12. So you subtract this, it gets to 0. So now we have this as a solution, and we have this as the polynomial. So what can we do now? We can solve this. If you know basic algebra, you can factor this. So this, and after you factor this, you get this. Those are our solutions. Now, of course, you guys can plug this into a calculator or use some kind of AI or graph it. You'll get the same thing. But now you understand the fundamentals. What first principles did we learn or review? We had the factor theorem, which tested your understanding of what it means when something intersects the x-axis on a Euclidean plane. And then we tested your understanding of long division. What is long division trying to do? It's trying to break any number, any expression down by its units, aka its powers, from its base. And then it starts with the highest power, the highest base, and it goes downwards from there. So once you understand these two principles, you can figure out and solve any cubic polynomial factoring. If anything confused you, just let me know. Leave a comment. And guys, there are other ways, especially in this situation. You actually could have had a trick, but that trick is not always reliable. That's why this is the surefire way. And on top of that, there's another way to do long division that is called synthetic division. We can explore that in the future, but synthetic division is not necessary for you to understand. Again, synthetic division builds on what we've just explored already. Break it down, think about the fundamentals, and you can derive the results, the formulas, etc. Hope you enjoyed. Keep learning.